In this video, we will discuss problems 7 and 8. With an initial speed of 6.5 meters per second, accelerates at a uniform rate of 0.92 meters per second squared for 3.6 seconds. Find the final speed and displacement during this time. So we actually have two that we're solving for. We want to know VF equals, and we want to know displacement equals. Our givens in this question are acceleration, 0.92 meters per second squared, and time of 3.6 seconds, and a initial speed, a VI of 6.5 meters per second. Okay, so we think about how to solve this. We remember this is a ratio. So without an equation, we can just say 0.92 meters per second. We can rewrite that meter per second squared into this relationship. For its simple, easy manipulation, I'm going to round this to 1. So this is approximate to 1. So this car is going to go 1 meter per second faster every second. So if it does that for 3.6 seconds, it's going to add 3.6 meters per second to the original speed. And the original speed was to the initial velocity, which was 6.5. So 3.6 added to 6.5 gives me a velocity somewhere around 10.1-ish. So this is an estimation of the answer I should be getting, somewhere around 10. All right, so let's actually do the problem with the formula and not use this rounded 1. So we need a formula that says VF equals VI plus the acceleration times the time. And that's exactly what I just did in my head there. Again, we're choosing from the formulas under constant acceleration because that's what these objects are doing, is constantly accelerating. So VF, we substitute in, is VI is 6.5 plus the acceleration, which is 0.92, times the time that acceleration occurred, which is 3.6 seconds. And so we're going to multiply this first, then add it. So we'll go, let's just go ahead and follow those steps for the sake of 0.92 times 3.6 equals, and that is 30.312. So we add that to our 6.5, and we get a final velocity of 9.81. And we need this to two significant figures, so we'll just go 9.81 or 9.8 meters per second. All right, so now we need to find our final displacement. And so our displacement formula, we have hopefully enough room to squeeze it in here, is we need a formula that says x equals, with the acceleration, the initial velocity, and the time that's occurred. So again, we're going to choose formulas from our uniform constant motion with it under acceleration. And we have this equation at the top says x equal, but it does not have a. So we have this formula down here at the bottom, and it does have acceleration and time in it. So our expression is going to be initial velocity times time plus 1/2 at squared. So we'll substitute in our information. We'll go x equals the initial velocity, 6.5, times the time that occurred, 3.6 seconds, plus any new motion, the motion due to acceleration, which is 0.92, times the time squared, which is 3.6. And I sometimes like to write that, I like to write it twice to remind myself to multiply it. So there's our expression, and our final answer will be x equals. So following the order of operations, we're going to multiply this and these two before we add them. So we'll go 6.5 times 3.6. All right, and we got that. So we're going to store that in our calculator. And then we'll go 0.5 times 3.6 times 3.6 times 0.92 equals. We're going to add that to our recall number. And I didn't store it correctly. So we'll go So we want to solve this by using our calculator, and we'll go 6.5 times 3.6 equals, and so we want to store that number, okay, and then we'll go 0.5 times 0.5 times 0.92 times 3.6 times 3.6 equals, and we'll add that to our recall number, and we get 26.38. We want to report that to two significant figures, so it's just 26. And our units would be a meter. Okay. All right, now let's look at number 8. Again, we have an acceleration, so we're using from that set of formulas where it is accelerating. We have an initial velocity of 7.0 meters per second, a rate of acceleration of 0.80 meters per second squared, and it does this for a distance of 245 meters. What's its final velocity? So VF equals question mark, so we're solving for the final velocity here, and we need a formula that says the final velocity squared equals the initial velocity squared plus twice any acceleration occurs and the distance that acceleration occurs. So the final velocity of this object is going to equal the square root of our initial velocity, which is 7. So don't forget to square that, plus twice the acceleration, 0.8, twice the distance that it occurs, 245, and we'll go down here and get our VF, okay? All right, so we know this is 49, and we're going to add 2, so 2 times 0.8 times 245 equals, we get 392 plus 49 equals, and we want to take the square root of 441, so square root, and we get 21. And then we got two significant figures in that number, 3 over here, so we'll report to 2. And turns out that our calculator has already expressed that into two significant figures.